So today we're going to do, we're going to talk about the final phenomena, okay, which is what we call the wave interference, okay, interference of waves. So far we have learned 3 out of the 4. Okay, so the first one is reflection, okay, go and come back. Okay, the second one is refraction, okay, that is caused by a change change in density. Okay, go and then it gets bent somewhere else lah. Doesn't come back, but it just changes direction lah. And then the third one is diffraction, which we saw last week. It's if it passes through a slit or if it passes through an obstacle lah. Okay, it's going to spread out lah. Okay, so it's slightly different. But interference actually is very closely related to what we saw last week, which is diffraction. Okay, but what I would like you to do now, okay, for the first 15 minutes, okay, is I'm going to send this link into the chat. Okay, actually, you know what? I'm going to send it into the Telegram group because if I send it to the chat, then people come in late and this one very susah. Okay, so I'm going to send it into the group. Okay, and what I need you to do, okay, what I need you to do is to go through this page. So you will be taken to this page. Okay, then what you can do is you follow the activity 1 inside your module. Okay, so inside the module over there, okay, what you can do is you can play with this animation lah. Okay, so this one now, this is pulse height. Pulse height will change the height of the wave. You can have, you know, one over here and then another one that is higher lah. So after you run in, okay, then you see what happens when the wave crashes in together lah. Okay, and then I would suggest that you start with the same height first lah. Okay, then after that you can change the height. But take a look at the blue and the red color lines, okay, during the superposition. Okay, so make sure that this is thick, okay, and then also make sure that the pulse width is the same. Okay, don't do one thin and one thick lah. Try to do both thick first lah. Okay, then you can play around with this. Okay, maybe for about 4 minutes or so. Read through all these notes here. Okay, and then after that go to the next page. So there's a second page to this lah. Okay, so when you go through this second page, I don't know whether you can see. Okay, you can. Now when you go through this second page, you will be taken to this one also. Okay, and you can play with this simulation also. Take a look at this red color wavelength and blue color wavelength. Okay, and make sure that it is in phase first lah. Okay, in phase first and then after that you can talk about out of phase because I want you to understand what is the meaning of in phase and out of phase. Okay, and then we see what happens to the wave when we do this thing which is called superposition. So what is superposition? Also is something that you need to know today. Okay, then the same thing, read through the notes over here. Okay, try to understand. Okay, and then after that, there's a third page. So 3 pages altogether. Okay, I will only send you the link to the first page now. So you go to the second and the third page together. So the third page is nothing really much. This one, I think they will just show it to you. Okay, but again, I want you to read this. Okay, read these points first. Okay, and I would suggest that for the third one, what you do is you set both the numbers the same. Okay, set both as 3 and 3, or you can set it as 2 and 2 if you want. Okay, if this is 2 and this is 2. For the beginning, after that you want to play around, you want to change this one, you can. Okay, then you can show it superimposed, or you can, and this is what I want you to tick. Okay, tick this one, show nodes and anti-nodes. Okay, and then I want you to see what is the relation between these nodes and anti-nodes. Okay, so the first 3 pages, okay, and I will give you about 15 minutes to do this. Okay, and then after 15 minutes, make sure as much as you can. Okay, and you need to do this together with your textbook. Okay, so if you don't have your textbook, please take out your textbook as well. Okay, I'm going to send you the link to this one. Open your textbook, okay, to this subtopic now, which is interference of waves. Sorry, it's like Christmas in my house. King kong, king kong, king kong. Okay, so what I would like you to do is answer everything as much as you can, okay, by referring to the textbook, in activity 1 only. Okay, for now we're just going to do activity 1. Okay, so I'm going to give you 15 minutes, which means 8:55 when we come back. I hope that everybody is ready with the answer, and then we can start discussing the answer. Okay, sending the link into the group now. Okay, I sent a link into the group. You know what? I'm going to copy into the chat. Okay, I'll see you in 15 minutes, everybody. Okay, everyone, let's continue. Okay, let's start with the first question. So we have a slinky. Yeah, I know we don't have a slinky but if we give a pulse at the end, okay, that is given simultaneously. So question number 1 is hold the slinky spring at both ends, okay, and then a pulse is given at each ends simultaneously. Okay, and so we want to observe what happens when the two pulses moving in opposite directions. Okay, for example, in this, let's say I have the same kind of pulse. Okay, now when they meet in the middle, okay, what happens to them? Okay, so we can see from here that after that, okay, then this one, look at this red color line. It continues to be, it seems to continue going. Okay, it seems to continue going even after they have already like sort of collided with one another. Okay, and that is kind of the most important thing over here. Okay, so there are two things. Okay, so the question is when the two pulses, when they meet together. Okay, so there are two things that happen. Number one, okay, they will overlap. Okay, as you can see over here. Okay, number one, when they meet, they will overlap. Oh, sorry. I didn't pause fast enough. Hold on. Okay, so they will overlap. Okay, they will overlap like this. Okay, but after they overlap, okay, what happens is they continue to move in their original direction. So these are the two things that happen. When the two wave pulses meet, okay, number one, they overlap. Number two, okay, they continue to move in their original direction. Look at this rate, it's going to the right. It continues to go to the right. Okay, it is not go and bounce back, go and bounce back. No, it's not like that. Okay, they will continue to move. And that's a very important thing when we're talking about waves that are overlapping. Okay, yes, they will overlap, but they will not bounce back. They will continue to go in the original direction that they were moving in the first place. Okay, so that's the answer to the first one. All right, secondly, the second question is compare the amplitude of the waves after they meet with the amplitude of the single waves before the wave pulses meet. Anybody want to try to answer this?
Sir,
I
don't understand the question.
Oh, okay. The question is compare the amplitude of the waves. What is the meaning of amplitude? Amplitude is the height of the waves, right? So when you compare the amplitude of the waves, you're comparing the height of the waves when they meet, okay, with sorry, actually it's not after they meet, it's when they meet. Okay, and the amplitude of the waves as a single wave. Okay, so if we take a look at here, okay, so now this one, the original one is I set the height as 3. Okay, when they meet or when they overlap, okay, what happens to the amplitude? The amplitude has become 1, 2, 3, 4, 5, and actually there's one more, there's 6 over here. But I can't, I'm pausing too fast. So how do you compare these two amplitudes? How would we compare? The amplitude when they meet will
The
be what?
amplitude when they meet is higher
Yeah,
than when they are apart.
correct. So the amplitude when they meet is higher than when they are apart. That's a very important thing. Okay, it's as if when they overlap, they don't just they don't just remain where they are. It's as if they combine together, and then after that they separate and go on their own separate ways. Okay, so there is a moment there for a very short while. Okay, there is a moment there for a very short while where they will it's as if this one plus this one, the blue color plus the red color will give you the black color. Look at the height of the blue and the red. 1, 2, 3. The blue also is 1, 2, 3. But when you combine both together, it's as if it's 3 plus 3. And it's as if both the waves they combine to form a bigger wave, and then after that they will separate and continue to move their own way. Okay, and this is what we call the effect of interference. Okay, so in a little while we'll talk about this. So that's the comparison lah. Okay, the amplitude of the waves after they meet is bigger, okay, than the amplitude of the single waves before the wave pulses meet. Okay, now write an equation, number 3, write an equation to relate both amplitudes of two pulses before they meet with the resultant amplitude after they meet together. Okay, so let's take a look lah. Let's consider this as 3 and this as 3. So just now I showed you that when they meet together, sorry, okay, when they meet together, you know what, I should do it a little bit slower so that I can pause it. Okay, so it's as if it is 3 plus 3 equals to 6. So the amplitude of the equation the equation would be, let's say this height is I call it x lah. Okay, so as if that the resultant amplitude, which is after you add the two amplitudes together, it will be x plus x. So it will be 2x. Okay, and that's what this one is lah. So it'll be x plus x equals to 2x. Okay, as if to show you that when the waves meet, okay, they will add together. Okay, especially if they are in the same phase lah, which will come to this in a little while. Okay, so that's the answer for number 3. Okay, number 4. What combining the two combining two overlapping waves, okay, can be explained by the principle of superposition. So obviously the question is, what is the principle of superposition? Anybody? Is that the question? Yeah. What is the principle of superposition? According to this, this thing. Anybody?
When two waves overlap, the resultant displacement is the sum of the individual displacement of the two waves.
Okay, very good. So the sum of the displacement, or when the two waves overlap, the resulting is okay. So it can be this, the algebraic sum of the two pulses. I think that what Ethan was reading to us just now was probably from the textbook. This one is also acceptable. The displacement of the medium from the equilibrium position when multiple waves interfere is equal to the algebraic sum of the displacement of the individuals of waves. So it's very long now. Okay, this is a very long and very long-winded this one. But what Ethan was saying just now is true. Okay, when the two waves overlap, okay, the resultant wave or the resulting wave, okay, is the sum. Okay, sum as in hasil tambah, okay, of both the waves. So you have wave number 1. Sorry, let's run this again. Okay, so you have wave number 1 here is 3, the height is 3, and then wave number 2, the height is also 3. And then when they meet together, okay, the sum will be about 6 lah. Okay, because it's 3 plus 3 equals to 6, and that is known as the principle of superposition. Okay, the displacement, the amplitude you just add together, okay, and that will give you the resultant wave punya amplitude. All right, good. Number 5. What is interference of waves?
The superposition of two or more waves from a coherent source of waves.
I didn't get that one word. From what is the word? From what?
From a coherent.
Oh, okay. So, Wong's answer: the superposition of two waves, okay, from coherent. Okay, I pronounce it as coherent, but I think if you want to say coherent, also can. Okay, so this is the idea behind interference. Okay, interference is the superposition. So we don't say, we don't use words like combining or meeting. Okay, so this is a new word that we need to get used to, which is the word superposition. Okay, to superpose, okay, to superpose means to overlap one another. And it's a very specific word that we use for waves, okay, and especially for wave interference. So waves don't meet, they actually superpose. Okay, And the word coherent, we will come to that in a little while lah. Okay, so interference is the superposition of two waves, okay, that come from coherent waves also can lah. Okay, so we will talk about coherent in a little while lah. Okay, so when we say interference, it comes from the word interfere lah. Okay, although in English, to interfere means to kacau lah. Okay, like to stop interfering, jangan mengacau, don't menyampuk lah. Okay, but in wave interference is something like that lah. You have an original wave and then you have a second wave that is like menyampuk the first wave. Okay, so we call this an interference. And cara dia menyampuk adalah dengan superpose. Okay, the way they interfere is by superposing. Okay, yeah, so all these weird words are superpose, superposition, okay, interfere, interference, all these are words that we will use in this particular subtopic. Okay, so you have to get used to these words. When the two waves meet, bila mereka berjumpa, we don't say meet anymore. We say they superpose. Okay, they combine. We don't say combine, we say they superpose. Okay, so wave A, the first wave, which is let me read. Okay, so the first wave is 3, the second wave is 3. When they meet, okay, when they superpose, okay, they will form a wave interference, which is a combination of both the original waves. Okay, that is the meaning of interference. Okay, all right. Let's take a look at the next one. So, complete by stating the correct type of interference for each situation. Okay, the first one is the superposition of two crests, which is like this. Okay, what is this type of interference called?
Constructive.
Okay, all right, it's called constructive interference, which is here. Okay, constructive means dalam bahasa Melayu, constructive is membina. Okay, it is a constructive interference. Okay, and constructive interference are when the waves are in phase. Okay, we're going to look at this word in phase a lot in this one. Okay, in phase means that, okay, in phase means that when you overlap these two, they're actually together. Okay, so this height and this height, this depth and this depth, crest with this crest, crest with this crest will form a bigger crest. Can you see that? The trough over here and this trough over here will form a bigger trough. So like xiamen and xiamen, okay, downwards and downwards will form a bigger downwards. Okay, they will superpose and they will form this one. Okay, but let's take a look at what happens, okay, when they are out of phase, something like this. Okay, so let's say this is a trough and this is a crest. Okay, when they meet together, okay, what kind of interference is that? I think that is the third one, right? Yeah. Superposition of a crest and a trough. What happens? What is that kind of interference called?
Destructive interference.
Okay, it's called a destructive interference. So this is the reason for this now. When waves are in phase, okay, the interference that happens is a constructive interference. It becomes an even bigger interference. But when they are out of phase, when a crest meets a trough, okay, so the red color is trough and then the blue color is crest, right? Okay, but they're slightly out of phase lah. Okay, what we will find is that they will destruct one another. Okay, actually this is a very small one lah. So when you see when they superimpose, look at this okay, over here lah. Okay, when they meet okay, this is the maximum that they can have. Okay, and this is not very good, this one. Let me make it even more out of phase. Okay, like this. Sorry. You see this? This is a crest and this is a trough. And what happens is it will be totally zero. If it is a little bit out of phase, you will still have a little bit lah, but not so much as in phase. If they are totally in phase, look at the interference. It becomes maximum. But when they're totally out of phase, okay, like one cat and one dog, right? Okay, it will just be like totally destructive interference. Okay, so these are all keywords that we need to know. Okay, and I want to slowly introduce this to you as we approach this subtopic. This subtopic is a very important subtopic. I always say this with all the subtopics, but this is a very important one, and I think it's important that you know all these words first. okay, and get used to these words before we actually go and, learn all the proper stuff. Okay. All right. So A and B, A and B, superposition of two crests and two, this one, sorry. Okay. So superposition of two crests or two troughs, okay, A and B, are both constructive interference. Okay, so jangan silap even though it's trough at the bottom, okay, as long as they are in phase, means trough meets trough or crest meets crest, they are both constructive interference. Destructive interference happens when both the waves are totally out of phase. Okay, let's say I impose them together. Okay, I put them together, I will get the crest meets the trough. The crest meets the trough, and it will totally cancel one another out. Okay, it will be 2 plus negative 2 lah. Okay, let's say the height is 2 plus negative 2, you get 0. Okay, all right. Now let's take a look at some of the definitions that are at the end over there lah. Okay, the table over there. Can I get a few responses? What is coherent sources? For coherent sources, then you have all this lah. Okay, so in physics, two wave sources are coherent if their frequency and waveform are identical. So this is from Google. Okay, but we need to talk about the waveform. Okay, what does it mean when the waveform is identical? Okay, so in our discussion, okay, when we talk about waveform, we also have to talk about the wavelength, okay, and a word which is called phase difference. I'm going to type this out in the chat. A phase difference. So there are three things that have to be the same when we're talking about coherent sources. Okay, number one, like what Wong said just now, is frequency. Okay, frequency. The second one is wavelength, and the third one is phase difference. Okay, so frequency, wavelength, and phase difference. I've typed it out in the chat so that you can copy. So coherent sources are waves, okay, or sources, sumber, okay, sumber. So coherent sources are waves that have the same frequency, the same wavelength, and the same phase difference. Okay, same phase difference means if one is crest, the other one is also crest. Cannot be one is crest and one is trough. That's not coherent anymore. Okay, so coherent and in phase and out of phase are very linked to one another. Okay, so if a crest and a crest, if they are both moving together, then we say that they're in phase. Okay, the phase difference is the same. Okay, when this one goes up, this one also goes up. But if let's say one is going like this, sorry, if one is going up and the other one is going down, so it's like that. Sorry, if one is, yeah, okay lah. One is going up and one is going up like this, and the other one is going down. So this is different phase. Okay, same phase, different phase. Okay, different phase. Okay, so in phase and out of phase, phase difference lah. Okay, the phase difference has to be the same, the frequency has to be the same, the wavelength has to be the same, and that's what we call coherent sources. Okay, secondly, the meaning of constructive interference. I think we've discussed this, but just want to make sure that you're getting it right. What is the meaning of constructive interference? Two crests in superposition. Okay, only two crests are Rahman. No, not just two crests. Think about when constructive interference happens. There are other dual case, bahkan. There are two cases where constructive interference happens. Two crests and, okay, two crests or two troughs. Okay, so constructive interference occurs when two crests or two troughs they are in superposition. Okay, and I'm going to add a little bit more at the end there, okay, to produce a wave with maximum amplitude. Okay, I'm going to add this in at the end. So two crests in superposition or two troughs in superposition, okay, that produces a wave with a maximum amplitude. It means you have one wave over here, one wave. When they superpose, they produce a wave in maximum amplitude. Okay, destructive interference.
Destructive interference occurs when a crest and a through in superposition to produce zero combined displacement.
Yeah. Actually, this is how no, thanks, Ethan. Okay, obviously that is the correct answer lah. You know, you have a crest and you trough a mid, and you produce a zero displacement. If you open your textbooks, it's actually in your textbooks. Okay, so constructive interference is this. Okay, so constructive interference in water waves, okay, happens. The water moves even higher and upper, okay, higher and lower. But destructive interference is seen when you have two waves that combine, okay, and you produce a calm water, lah. Okay. Now in light waves, okay, in light waves, when constructive interference happens, we will see a bright region, okay, and when destructive interference happens, we see a dark region. Okay, now for sound, okay, in sound waves, if you've noticed now, we always talk about water waves, light waves, sound waves. So in interference also it's the same thing. Now in sound waves, we have loud sounds, okay, when constructive interference happens, you have this original sound plus another original sound. When they combine together, it emits a much bigger sound. Okay, and destructive interference will be silent. Okay, silent means because they destroy one another. You have one sound and the other sound, but since they're not in phase, okay, you have one crest meeting with one trough, so you're gonna get a softer sound, okay, or even worse, you're gonna get a silent sound. It is actually possible to cancel out sounds, okay, but they need to be totally out of phase, okay, like the simulation I showed you just now, lah. One crest and one trough when they meet, wow, totally out of phase, and then they will form a zero sound. It's very difficult to achieve this in real life, but it is possible. Okay, antinode is a point, okay, where constructive interference occurs. Okay, antinode is the point where constructive interference occurs. A node is a point where destructive interference occurs. Okay, antinodal line is a line that connects all antinode points, and a nodal line is a line that connects all node points. All these are actually in the textbook. Okay, and also in the, well, actually it is briefly mentioned in this one lah. Okay, but I was going to show you where this is in the textbook lah, but never mind lah, since already in the slide, so I'm sure you can copy this down. Okay, but these are other points, okay, these are other things, another 4 words which are very important when we talk about interference. Okay, we need to know what is antinode, we need to know what is node. Okay, so an antinode is where a crest meets a crest. A node is where a crest meets a trough. An antinodal line is where all the antinodes, you connect them together, you get an antinodal line. Okay, and a nodal line is where we connect all the nodes together. Okay, we will form a line, and usually we find that they will form a straight line. Okay, they won't form a zigzag line lah. Okay, so when you join all the antinodes together, they seem to form a straight line. Okay, and we will actually see this on Wednesday's class lah. Okay, when we do the activity.